let's take another look at solving some absolute values graphically. I would like to still go with the root zero method. It's one of my favorites, and it causes less complications. So with both of these, part A, part B, I want to remind you that in both cases, if you look at the related equation, all it's doing is taking the absolute value of 2x plus 1 plus 7, and you're replacing the inequality symbol with an equal sign. So if we were trying to solve the related equation on our TI, in order to do this, we have to isolate everything on one side with 0 on the other. So my preference is to rewrite, I think I'd be moving 3 over to both sides. It's a little easier to move it over to the left. So I should get the absolute value of 2x plus 1. And of course you can do the math, but I've just let the TI take care of it. There's more on my mind, so I'd rather do that. Plus 7 minus 3 equals 0. So right away, you end up having what your y1 would be. So we can enter that in the TI, but as I go, you may kind of notice if I'm looking at part A, it's similar. This would give me 2x plus 1 plus 7 minus 3 is less than 0, according to if we moved everything over. And part B would give us absolute value of 2x plus 1 plus 7 minus 3, and go with the greater than 0. So remember, we're just looking at the corresponding inequality. And once you move everything to one side, whether it's an equation or an inequality, if you notice, all of the entering for y1s will be the same. So let's go ahead and we'll enter that in on our calculator. Move over to our TI. And we press the y equals for the function editor. Again, to enter the absolute value, we have to press the math key. Scroll over 1 to the number menu. Select ABS, absolute value. And we'll enter in the 2x plus 1. And we should have a plus 7. Oh, be careful. Sometimes it moves a little fast. Plus 7 minus 3. So we press enter, we graph it, and then we notice with the behavior, sometimes if you're looking for, remember, if it's the root zero method, you're looking for where it crosses the x-axis. And sometimes you have to adjust your window to see if it crosses the x-axis at all, but we know the behavior of these absolute value functions. We've got a V shape. I don't believe it's ever going to come back down around and cross the x-axis. So that's going to be an interesting idea. And that kind of gives us a clue about some of our special cases. Remember, we were talking about those earlier. So first thing I will do is, there's no way I can't calculate a solution to the related equation. It never crosses the x-axis, but we still have to sketch our graph. So let's just copy that over. I'll try to be relatively accurate. So with my graph sketch, very valuable work. It looks like to me, when I'm referring to my calculator, it looks like the V shape, the point of the V is a little to the left of your y-axis, and it's above the x-axis. So there's my graph, my y1. And what I want to look at, I have to interpret this. Usually when you're trying to find solutions to these absolute value inequalities, you care about the solution to the related equation. But because we're using the root zero method, there's no zeros or x-intercepts that exist. So there's no solution for the related equation. So that's great, but that doesn't help us out with our inequalities quite yet. So we're going to have to do some interpretation. So remember what we called the left-hand side of the equation y1. And if we're looking at part A, we're looking at less than 0. So you're trying to ask yourself again, and it helps to restate it in English, what values of x give me or give you y values and less than 0, what does that mean? Less than 0 means negative numbers that are negative. So if you're kind of looking at your graph to interpret this, remember, like we used to talk about how the boundary points, the solutions to the related equation, would help us see if we have to break up the x-axis into certain regions. Well, if you look at your x-axis, there's no zeros, but you want to kind of look at this and interpret, does your graph ever have a negative y value? And if you're not sure, you can kind of pick a test value and notice that if you travel, corresponding y values, no matter what you do, are always positive. So when I look at part A, the values of x that give y values that are negative, none exist. And if that is the case, you would say that there's no solution. Or sometimes people like to write the null set. So that would be the response that you would have to write for part A. You can't just leave it blank. Now I like this way a lot better. When I graph, I can clearly see, yeah, the function never has a negative y value. It gives me a really good reason, and it backs up my analytical answer a lot. So that's the good news. Same idea for part B. You're probably looking at it in a slightly different way. We're going to look at y1, but we're looking at greater than 0. And earlier, if we're translating English, again, we're asking what values of x give y values that are what's greater than 0. Greater than 0 means positive. And so we kind of notice with part A, we kind of mentioned to ourselves like, oh, the y values are always going to be positive. So technically, every single value on the x-axis that we've highlighted in teal is going to give us a positive y value. So special case again, part B, all of them do. All values of x. Whoops, I'll write values a little nicer. Make this true. So part B actually has a solution, and the solution is all real numbers. But usually if you're writing in interval notation, you will see this as negative infinity to positive infinity. So this is what I would respond for part B. So isn't that interesting? Your related equation could have no solution, but your inequality might have a solution of all real numbers or no solution. And I really like to see the graph. It really justifies why I'm answering the way I am. So I really encourage you, get really good at this reading graph business. I really like the root zero method. I would prefer to use that for all these functions and above. I hope this is helpful to you. I will see you next time.